Alrighty, so we're trying to solve, instead of just figuring out where the absolute value equals a number, we're trying to figure out where an absolute value is less or less than or equal to, or even greater or greater than or equal to. Now, I know it's been a while for some of you, so I'm going to come over here to the side, and I'm going to write that that means less, and that means greater. If you remember that and you don't need that, that's fine. But let me just remind you that that's what those mean, because sometimes that gets a little bit confusing. The part about the bigger part being at the, the alligator and all of that, I just remember that it's always pointing at the thing that's less. Okay? That's the way I think about it, is it's always pointing at whatever's less. So, in number 1, we're trying to figure out where the absolute value is less than 3. And notice in these first few problems, the graph is already there for you, but I'm going to also show you there's a couple ways that you can graph it and look at the answer. So when you think about a problem like this, you can start off by thinking about like whatever's over here. Usually it's a number. In this case it's 3. Okay? And looking at the graph, it tells me this right here is the 3. Okay? The question says, where is the absolute value less than 3? Well, the absolute value is the V thing. And so I want that V thing to be less than the 3, or less than the blue. Which means when I'm talking about less or greater in this case, I'm thinking about above and below whatever it is that we're looking at. Okay? So this is the less part. That yellow is the less. Okay? And most of the time students have no trouble trying to figure out which part it's talking about. The problem is writing down the answer. And so that's what I wanted to look at with you, is how you actually write down the answer here. What you do is you find out where they intersect. Okay? And we think about this negative infinity and infinity thing. Okay? Negative infinity, like when I think about that line right here, negative infinity's over here, infinity's right here. And then those two intersections are the x values. So, negative 2 and 4. Okay? So, my answer is whichever interval where it's highlighted. Okay? It's highlighted right here. So, the interval I'm interested in is there to there. Okay? If it was highlighted here, then I would be interested in these two intervals. So, it's just wherever it's highlighted. It's highlighted here to here. So, our answer is negative 2 to 4, like that. It means any number between negative 2 and 4, if I plug it into that equation, it would work. Now, it would have a bracket, like we've talked about before, if it's equal to, like it is on this one right here. Okay? It's not equals right here, and that's the reason we have a parentheses. Okay? Any questions about that one? Alright, let's look at the next one. Alright, I always start off with whatever it's talking about over here, which in this case is the negative 4. So I'm going to highlight that negative 4. It points at that line and it shows me that that's the negative 4. And the question says, where is the graph, the absolute value, less than or equal to negative 4? Okay? And negative 4 is that blue line. So I want the absolute value to be less. Okay? If this is the blue line, I'm wanting to know what's below the blue line. Okay? In this case, there's two parts to it. It's here and there. Because there's two parts below the line. Alright, again, I'm going to put negative infinity over here. I'm going to put positive infinity over here. And I'm going to think about these two intersections, where they intersect. Okay? This looks like it intersects at -7 and at 1. The part that's highlighted is my answer. There's two parts that highlighted, so that means there's two parts to my answer. So it's both of these two pieces right here. Okay. So we get -infinity, -7. That equals right there means I'm going to have a bracket. Okay. And then 1, infinity. Again, the equals means I'm going to have a bracket. You never have a bracket on infinity or negative infinity. Now, both of these problems can be done a different way. And so I want to make sure that you see both ways, in case you like it this way or in case you like it another way. Okay? So I'm going to go to Desmos real quick. And I want you to see what would happen if I put this equation in there just exactly like that. Okay? So let's say I put absolute value x minus 1. Notice here's less and greater and equal to and all that kind of stuff. We want less, so I want this one. And then 3. What's it not doing? Oh, I forgot to put the rest of my absolute value. Sorry. The absolute value has to end. I've got to move it over. Sorry. And then less than 3. Okay, now, this graph looks different than this graph. But this graph also gives me the answer. Okay? It's one part that's shaded. Right here where it touches the x-axis, see, and it doesn't click on it, so you'll have to count it, but it touches the x-axis at -2. It touches the x-axis at 4. And those dotted lines there, that means there's going to be a parenthesis. So, this will give us the answer if you put it in exactly the way it's written, if you can understand what that means as far as the picture goes. Questions? You still use the boundaries, like that dotted line there, as the boundaries. And because it's shaded between, I know it's that middle part and it's just one thing. Let me show you what number 2 would look like in Desmos. So, x, I'm just going to retype it, negative absolute value x plus 3 less than or equal to -4. Okay. Again, that looks very different, but I can tell that there's going to be two parts to my answer. Okay. Wherever it touches the x-axis, those parts right there, which, like I said, it's hard to tell because you can't click on it, but 1, 2, 3, that's at -4. No, it's not. It is going by different values. Oh, here we go. There's the right one because they're going by 1. So that's at -7, that's at 1. And then it's going from -infinity to -7. And then 1 to infinity. Alright, so because it looks like that Desmos might be a little bit easier, let's just graph it in Desmos and see what happens. This first one here, we're going to do, there's 2 questions there, but we'll do them separately. Absolute value, x minus 1. Make sure you move it over. Greater than or equal to -2. Okay? It's all purple. There's nothing going on here. What that means when you can't find anything that's not shaded is it means that the answer is all real solutions. It means there's not an interval that doesn't work. Okay? Now, you should, like you saw how I zoomed in and out, you should zoom in and out a little bit, at least to make sure that we're correct, that that is true. But it does look like that. Now, I want to explain on this graph why it's true, but, you know, Desmos gives us the answer. So, if here's that -2, the question is, where is the graph greater? Here's -2. It wants to know where's the graph above it. Well, where is the graph above it? It's always above it. Okay? Because it's always above it, that means it's all real solutions. It means every solution works. No matter what number I put in there, it will always be greater. Okay? And if I put in the next one, it says less. So let's put in that less. Zoom out. Do you see any shading? There's no shading there. And that makes sense. Home will always take you back to the beginning, by the way. But it makes sense when I think about the graph, because if here's the graph and it wants to know when this is below it, well, it's never below it. Okay? And so this would be no solution. That's kind of a tricky one, but I wanted to make sure you had seen that one. Alright, so here's what it looks like in Desmos. Remember that the dots that we see means there's going to be parentheses. There's only one thing shaded, so I know there's only going to be one answer. And you do have to count to figure that out, because you can't just click on it, but it looks like it's -2 and then +2. So -2 and then +2 like that. Okay. Let's do a couple more. I'll go ahead and put this one in. Absolute value 1/2 x plus 2 is greater than 4. Okay, this one has two parts that are shaded. Because there's two parts that are shaded, I know that I'm going to have two parts to the answer. Okay? And I know on the ends of the two parts are negative infinity and positive infinity. Okay? And also I know it's a parentheses because I see those dotted lines. And there's not an equal right there. Alright, and then I figure out where those dotted lines are. It looks like it's at -4 and +4. And so there's our answer. Alright, and then this last one, it's a little bit tricky because our line, you know, that y equals x, it doesn't go straight across. But we will see if it changes anything as far as the way the graph is concerned. So we'll have -3, absolute value, x minus 2 plus 4, and then greater than or equal to x. Doesn't look like anything changed. I still can tell how many answers there's going to be. It looks like there's just going to be one answer. There's no dotted lines, so I know I'm going to put brackets and then a comma. And then I just need to figure out these values here. It looks like it's at 1. And it's a little bit tricky here because it's in between here, but it looks like it's at 1 and maybe 2.5. If it gets like that and you can't tell for sure if 2.5 is the correct answer or what the decimal should be, you might need to graph both pieces. Like there's one side, there's the other side. When you find those intersections, that'll tell you for sure what those are. So if it gets to the point, because you can't click on it whenever you put in the whole thing. So if it gets to the point that you're not sure exactly what is that value where it's intersecting, is it really 2.5? Is it 2.4? Is it 2.8? You can graph each side separately in Desmos and just look for those intersections. And it's the x value. These happen to be the same, but it's the x value that you're looking for. Alright, so I have them all graphed, but I'm just going to come over here and turn them on one at a time. So this is number 7. And notice I did have to zoom out a little bit to try to figure out where that shading was. It almost looked like it was all real solutions, but once I zoomed out I realized it's not. There's just one answer, so I know there's a parentheses like that. And this is going by 50s. The only hard part here is trying to figure out where those intersections are. But it looks like it, you know, it's going by 10s each one since I see the 50 and the -50. So it looks like that this would be -40 and then +40. And again, if you weren't sure, you could graph these two parts and find the intersection. Alright, I'm going to turn that one off. And turn the second one on. That's this one here. I'm going to go back home because it looks like it's closer to the original equations. Alright, I see two parts. When you see two parts, you know that you're going to have something like this. There's the equals there. Also, it's the solid line, so I know we're going to have brackets. Okay? And then we're just going to count it. It looks like this is at -6, and this is at +4. So, -6, +4, and then the ends are always -infinity and +infinity. Alright, then let's look at the next one. Turn that one off and turn this one on. I zoom out, and I zoom out really far. Notice nothing's happening. That doesn't mean it won't, but most of the time if you get really far like that and nothing happens, that means that our answer is going to be no solution. Alright, and then let's look at the last one. Turn that off, turn that one back on. Let's zoom out. I'm never seeing just one shading or two shading because that never changes. That means that this one is going to be all real numbers. And then one other thing I want to tell you, sometimes you might see all real numbers written that way. I just want to tell you that, just in case, if you have multiple choice, you never know what the answers may look like. That might be another way to write all real numbers, kind of like we talked about with domain, how it could be written that way. No solution also could be written with a 0 and a line through it. That could also mean no solution. So I just want to make sure you saw that, that notation.